So now I'll get into the discussion. I'm just gonna go off these questions. So the first question is, why does this phenomenon occur? We've been studying chirality and chiral centers, and this actually affects the way the light comes off of the molecules when you have it, like an R or an S enantiomer. It'll actually rotate the light. It causes a phase shift in the light. So actually, this is exactly what the polarizing films do as well. They're created so that they cancel out all light except in one phase, this way or that way. And when they're perpendicular to each other, light that's phased this way can't get through, and light that's phased this way can't get through. So it ends up no light getting through, and you get black. Now, the molecules are actually doing something really similar, it actually compounds with the polarizing filters, and that's kind of the point of the experiment, is that by measuring the different angles of the polarizing filters, because we're no longer canceling all the light this way, now we need to adjust them to cancel all the light, because the molecules within the solution are also polarizing the light somewhat. As you observed in the lab, why do the various compounds alter the results? So they alter the results based on the degree that each molecule rotates the light. That's why it's called the specific rotation, because it's specific to that molecule. It'd be odd to think that two completely different molecules would rotate light the exact same way, and they don't, obviously, because the specific rotations for these three and the measured rotations, the observed rotations, were all extremely different. So it's clear that they're all affecting the light to different orders. How do you know these molecules are all optically active? If they weren't, then there would be a 0-degree observed rotation. All the work would be being done by the polarizing filters, and the molecules inside the solution wouldn't be affecting the polarization of the light at all. How does concentration, purity, and identity of substance affect the result? It's important to have the concentration in there, because that'll tell you how many molecules are in such an area. That's the concentration. So that's how many times, essentially how many different molecules the light has to pass through to get out of the solution is going to affect how much it rotates and phase shifts. Purity, I assume that means like how much of R and S are in there, and that kind of gets into the racemic, I think that's how it's pronounced, mixtures, where you can affect actually how much is phase shifted, because you can start mixing stuff that the two different enantiomers will shift it by the exact same amount, only in opposite directions. So you can almost create your own polarizing filter, a non-polarizing filter, because they'll exactly cancel each other out and the light won't be affected at all by having each of the two others. And the identity of the substance, I'm not exactly sure. I need to study the book a little bit more to actually know how the light interacts with the molecules and how it spins them and how it phase shifts the light, more importantly. So I'll just go on to question 5. What has to occur for the phenomenon to be observed? You have to have an optically active substance. That means a substance with a chiral center that has like an R or an S configuration, because that's what's actually kind of doing the work here and giving you this polarizing effect. It's not polarizing like the sheets are, but it is like fractionally polarizing.